Kia ora Year 11. In this video I'm going to go through question 2 of last year's MCAT, and so this is day 1 of last year's MCAT. I'll get on to day 2 next week sometime. And in this part we've got 5 questions, so I'll just scroll through them quickly. So the first one, where we have to find the perimeter of a shape, is an achieved level question. And then in the second one, if you get it completely right, you'll get an R for merit. And then in question C and question E, you can get credit all the way up to excellence credit, so that's a T question, and D is another R question. Okay, so I'm just going to work through them slowly. Make sure that you have a go at them as you're watching the question, and make sure that you're writing down the algebraic working in your maths book so that you've got something to look at later on. So in the first question, we're told that the perimeter of the shape below is 34 centimetres. So that means that if I add up the lengths of the sides, that's going to give me 34. And what we have to do is write an expression for the perimeter, set it equal to 34, and then solve for x. So adding up those side lengths gives me x plus 3 plus x plus 2 plus x plus 2x minus 1, and that equals 34. Collecting up the like terms, I get x plus x plus x plus 2x gives me 5x. And now we've got the numbers, we've got plus 5 minus 1 gives me plus 4 equals 34. I'm going to subtract 4 from both sides and get 5x equals 30. And next I'm going to get x is equal to 6 centimetres. So we're asked to find the value of x, and that's what we've done. So that's a little achieved question. Okay, in the next one, we've got an inequality to solve. So we can see that we've got a quadratic on the left-hand side and a quadratic on the right-hand side. We're going to expand both of those and then try and clean it up. So collect up some like terms and hope that it simplifies quite nicely. And it turns out that it does, kind of. So let's just start by writing it out. We've got 3x plus 2 times 2x minus 1 is less than or equal to 6x plus 1 times x minus 3. Now I'm going to work the whole way through with this inequality, and the thing I've got to watch out for here is not to multiply or divide by a negative without changing that sign over. But we don't have to do that yet. All we start off with is a bit of expansion. So 6x squared plus 4x minus 3x minus 2 is less than or equal to 6x squared plus x minus 18x minus 3. I'm going to clean up my like terms. So 6x squared plus x minus 2 is less than or equal to 6x squared minus 17x minus 3. Now I'm going to subtract 6x squared from both sides, leaving me with x take away 2 is less than or equal to negative 17x minus 3. And the next thing I'm going to do is gather up my x's onto the left-hand side by adding 17x to both sides. So x plus 17x will give me 18x here. So all I've done there is I've added 17x. So I don't have to change the sign because I'm just adding something to both sides. And lastly, I've got 18x minus 2 is less than or equal to negative 3. I'm going to add 2 to both sides, giving me 18x is less than or equal to, so negative 3 plus 2 gives me negative 1. And if you need to use a number line to check that, we're starting at negative 3 and we're going forwards 2 units, so we get to negative 1. So finally, we need to solve this for x, and we've got 18x is less than or equal to negative 1. I'm going to divide both sides by 18. That gives me x is less than or equal to negative 1 over 18. And that's my final answer for that one. Okay, what's next? Oh yeah, this one. So we've got a perimeter of rectangle A is 46 centimetres. So the perimeter of rectangle A is going to be 7p plus 3q, and then the same thing again. And the perimeter of rectangle B is 32 centimetres. So we've got 5p here, 5p up here, 2q here, and 2q here. The first step is to write expressions for the perimeters and then set them equal to 46 and 32 respectively. Okay, so the perimeter of A is 2 lots of 7p plus 3q, and that has to equal 46. And the perimeter of B is 2 lots of 5p plus 2q, and that has to equal 32 centimetres. Now, there are a couple of ways to go here. For those of you who are not that confident, probably what you're going to do now is you're going to expand out this 2, and that's fine, and I'll do it that way. And we get that. And then here, again, we expand out 2 times all of this, and we get 10p plus 4q is equal to 32. Now, the other way that we could go straight away here is we know that this is 2 times all of this. So we could divide both sides by 2. And the same thing here. I'm not going to do it that way for now because I want to make sure that pretty much everyone watching this can understand what I'm doing. But I would probably, I am going to do it this way actually. I'll do both ways. So the fast way to go from here is just to go straight to this. 7p plus 3q is equal to 23, and 5p plus 2q is equal to 16, right? So I'm dividing both sides by this factor here to save myself all of that expanding work. But it doesn't matter too much anyway, because what we're going to get is a pair of simultaneous equations. So I'm going to work with the ones that I think most of you would have ended up getting, which is this one here and this one here. We're going to put those together and we're going to line them up. We're going to solve them to find a value of p and a value of q. And from there, what we have to do to answer the question is to go back and find the length and width of the rectangle. So the final answer has to give the dimensions for each rectangle, but the first step is to find the individual values of p and q. I'm going to use elimination to do this. I know that lots of you in Year 11 don't like this much, but it's a great method for solving problems. So let's have a look at it and see what we want to do. Well, we want to end up with being able to take one of those away from the other and have only one variable left. To do that, we need the coefficients to match. And we've got a 6q here and a 4q here. We've got a 10 here and a 14 here. So at the moment, they don't match. What I'm going to do is the same thing to both equations so that I can match up either the q or the p. And in this case, I'm going to match it up so that I end up with the same coefficient for the q. I'm looking here for the lowest common multiple of 6 and 4. So I'm going to times the top one by 2 and the bottom one by 3. And I'm going to do that to the whole equation, right? And then I'm going to times the whole of the bottom equation by 3. So this is what we get. We get 28p, whoops, let's just fix that. 28p plus 12q is equal to 92. And the second one will give me 30p plus 12q is equal to 96. So just watch that I've done every single term in here. I've times in this one by 3, and every single term in here I've times by 2. Now I've got the 12s matching up. So I can work out now what is equation 2 take away equation 1. So 30 take away 28 gives me 2p. And here I've got nothing, which is what I want. And then 96 minus 92 gives me 4. 2p is equal to 4, so p is equal to 2. And now I have to find q. So I can find q by substituting this into here, or into here, or into here, or here. It doesn't matter. They're all going to work. So let's go for this one here because the numbers are really easy. So 2 times 10 plus 4q is equal to 32. 20 plus 4q is equal to 32. Taking 20 away from both sides gives me 4q is equal to 12. Q is equal to 3. So we've just about finished the whole question, but remember we had to get the dimensions of the rectangles. And the dimensions for the rectangles, let's see what A was. Well, A had 3Q here, and it had 7P here, and B had 5P here, and it had 2Q here. So A has length of 7P, which is 14 centimetres, right, 7 twos, and it's got width of 3Q, which is 3 times 3, so that's 9 centimetres. And then B, I don't know, I've called that the width. So width is 5P, so 5 twos are 10 centimetres, and the length is 2Q, which is 6 centimetres. Okay, so that's that question completely finished off. If you're not confident with solving simultaneous equations, they come up over and over in the MCAT for excellence, and it's really important that you can do both the substitution and the elimination method. So if you want some extra practice, either EP, or I'm sure the Walker workbook have got lots of that, and also Dr. Frost. So let me know if you want me to find you some Dr. Frost key skills on this one. Let's look now at D, which was a merit question. So we've got an equation with fractions. Now, there's nothing to freak out about in here. The basic rule when we've got fractions is that we have to get a common denominator if we're adding or subtracting. So that's going to be 15 here. The other thing to watch with a big flashing light is that here we've got a minus sign. So I want you to remember that this line here, the division line, is acting as an invisible bracket around everything on top of it. So what we're going to do now is we'll get a common denominator here, and we're going to have 3 watts give me 15, 3 5, so 5 times x plus 2 minus 5 watts give me 15, 5 times 3, so it's going to be minus 3 times 2x minus 1. Now, I hope you noticed that it was really important that we put that in brackets, because we're going to have a negative times a negative in here. Right, on the next line, I'm going to times both sides by 15, giving me 5 this, and we get 5x plus 10 minus 6x plus 3 is equal to 15. Negative x plus 13 is equal to 15. Negative x is equal to 2, and x is equal to negative 2. So I've got 2 minutes to do the last question, which is the excellence one. And the key to it is looking at what we're given. So we've got a rug which is 3 metres long and 2 metres wide. So the area of the rug is 6 metres squared. The area of the whole room is double the area of the rug. And we have to find the area of the border, which is all of that. So it's going to be the difference between those two things. And the border is x here. So on my diagram, I'm going to write on how long these sides are. Now I'm going a little bit quickly here, but we know that this side, this is x, this is x. So that's 2x plus the 3 here. And this one here, this is x, and this is 2. So this is 2 plus 2x. So the area of the border will be the area of the whole room, which is this times this, take away the area of the rug. I'm going to do this very quickly in 1 minute, okay? So we've got room minus rug equals border. So 2 plus 2x times 3 plus 2x minus 6 has to equal 6. I'm going to rearrange those. So 2x plus 2 times 2x plus 3 minus 6 equals 6. Expanding that gives me 4x squared plus 10x minus plus 6, take away 6, equals 6. I'm going to subtract 6 from both sides, and now I'm going to divide through by 2. 2x squared plus 5x minus 3 equals 0. Factorising that, I can do by inspection because this is a prime and this is a prime. So we've got 2x times x, and then we've got a 3 plus a 3 and a minus a 1. So 2x equals 1 and x equals a half, or x equals negative 3, but we have to have x is greater than or equal to 0 because it's a length. Okay, important that you say that for excellence. So x is equal to 0.5 metres is the value, is the border width. I think that's what we had